Hello friends, welcome to Code Sutra. In this video, we'll be solving LeetCode problem number 28. In this problem, you are given a string, for example, hello world, and you are given a pattern, for example, world. You have to find if this pattern is actually present in the main word, that is hello world. Is it present? Yes, right. So how did you say this? You just looked at it and you said this, right? But the computers can't do like that because they are dumber machines. So you have to devise an algorithm to say if this word is actually present in this string or not. So we have to design an algorithm. So let's dive into how we can design an algorithm. The first thing is we can compare letter by letter. For example, what is the length of this string? The length is 5. So we'll choose the first 5 letters, hello and word. Are they same? No, right? Because the first character is only not matching. So there is no need to check any further. We can declare hello is not equal to word. Then we will actually go to the next 5 letters. That is hello and word. Are they same? No, because the first character is only not matching. So they are not the same. Then again we go to LLOW. Are they same? No, L won't match with W, right? So finally when we go to word, all the characters match and we have the string. So we'll be returning yes and the index of W. But this is very easy because why? Because the first character is only not matching, right? But let's take a very complicated example. Let's take this example. Okay, this is the main string and this is the pattern that you want to find in this particular string. So if you want to try to find this pattern and this is this, the first characters are same, the second is same. You have to go until the last character to find out if these two are same or not. They are not same, right? But when did you find it out? You found it out only when you reached the last character. Similarly, again you have a similar string and again you will be doing from the first to last, right? So this is not a very good approach, but this definitely helps you to solve the problem. But can we devise a better approach? Yes, definitely we can try to design a better approach. What is the better approach that we have? The better approach is we will hash this. For example, this will have a unique integer value and this string will have a unique integer value. So you can just compare these two values. If they are not same, right, there is no need to compare the characters at all. For example, let's just add these strings. For example, a equals 1 and b will be equal to 2. Then again a will be equal to 1 plus again 2 plus again c will be equal to 3. What is the sum? The sum will be equal to 9. Similarly, what will be the sum here? It will be 7, right? So are they same? No, they are not the same. So there is no need to compare at all, right? But if you try it, why are we even doing this? Because again we are adding the characters one by one, right? So it will take the same time complexity. Yes, but the next string, right? So the next string A B A will get changed to B A B. So all you need to do is subtract A and add B. So what is subtract A means? You are just subtracting 1 and adding 2 to it. So you at A, so whatever be the length of this string, you just need to perform 2 operations to find the hash of a particular string. That is, you are subtracting the first character and adding the next character. So it will be very easy to find. So this will be equal to 8. So can we use this very simple formula? Let's find it out. For example, let's take this example, right? Very huge example. So what will be the hash of these two functions if we use this previous approach? That is, a equals to 1, b is equal to 2 and so on. Can we use this? No, right? What I have done is I have just interchanged f with e and e with f. Will the hash be same if we use the same formula? Yes. Why? Because there is no importance given to the position, so they will have the same hash. And again we will have to do the comparison from the first, a is equal to a, b equals a. Then only when you come to f, you find out these two are not equal. So we have to change the approach to calculate the hash function or the hash value, which actually gives the importance. So we will use a very complicated formula. So this is the complicated formula. I will explain this formula, why we are using this. So in order to give the importance to the position, what we are doing, we are raising the power to the position. For example, the first character 0, then 1, then 2 and so on until n minus 1. Why are we doing this? Because we have to give the importance to the position. For example, this position and this position. But why are we raising it to the power? Can we just multiply? No, right? Because for example, 4 into 3 is also equal to 12. 6 into 2 will also be equal to 12. So there will be more collisions, right? So that won't be much useful. So what are we doing? We are raising to the power. So why are we multiplying it with the prime number and raising it to the power? Again the same thing. 4 cube is also equal to 8 square, right? So in order to avoid these collisions, we are multiplying it with the prime number that is actually raised to the power of this particular position to find the hash. So once you have found the hash and these two hash functions or hash values are same, then again what you do, you compare each character, and if each character matches, then you have found the answer. There are very less possibilities that these hash values can actually be same, but can they be same for two different strings? Absolutely yes, but the chances we are reducing it to very low, and we can find the answer using this approach. Dive into the code. So what are we doing here? We are just initiating the variables n and m that is equal to the length of the string and the pattern that we want to find. And if the substring length is actually greater than n, is it possible? No, right? So we will just return -1. Next we initiate prime is equal to 101, and these are the hash values of the substring and the main string. So we will compute the hash value of both the substring and the first similar characters in the main string also. For example, hello and world, right? So we compute the hash of hello separately and word separately. So that is what we are doing here. We are computing the hash of the main string and the substring. So if you look here, if they both are same, what do? We compare each character and we try to find out if they are same. Okay, then what are we doing in the next step? What we are trying to do here is we are just computing the hash. That is, we are subtracting and we are just adding the next letter here. So if you look here closely, we are not at all changing the hash of the substring or the pattern, but we are every step changing the hash of the main string. And if they are same, we will just compute if every character is same. If all of them are same, we will just return the particular index. If not, finally we will return -1. Thank you for watching the video. Please do like, share and subscribe.